Okay, and now we cut to the actual use of this. So we know that x plus y to the 400 is 401 terms. All the way. And these numbers you gotta figure out and choose R if you remember. That's from the binomial theorem in our college algebra or using Pascal's triangle. But a plus bi to the 400 is c plus di. So what we need to do, either multiply this by itself 400 times, which is not realistic unless you have a lot of free time on your hand. But if I can write this as again, they're not asking for the graph, but it's a good idea. 1, 1, r is 2, and the angle is pi over 4. And this is nothing more than you using algebra. You multiply those, that would be 100 pi I. And that would be, we want the answer in complex form. So that would be 2 to the 400, no need to figure that out. The cosine of 100 pi plus I the sine of 100 pi. So that is 2 to the 400 times. We know that pi is right there. Cosine is -1 and sine is a 0. So we know this is going to be -2 to the 400. And there it is. I could tell where that is. I know that is on the negative x-axis. So I know the location of that. That's very important in applications. And if I look at this problem, I'll say, right, well, again, as it is, it's very hard to do. But if I am to figure out what this is in polar form, we move -2 to radical 3. Now we can figure out what r is. R squared is 2 radical 3 squared plus a -2 squared. R squared is 4 times 3 plus 4, that is 16. So we know r is 4. So I could write this as 4. And the angle, I know that tan of theta equals 2 radical 3 over -2. Tan of theta equals negative radical 3. And I'll draw this for both problems. There's 30 degrees, part B and C. 1, 2, radical 3. Tangent is radical 3 of 60 degrees, or pi over 3. In the second quadrant, that is 2 pi over 3i raised to the 36. That is 4 raised to the 36 e. If I take 2 pi over 3 and multiply it by 36, that divides this 12 times, and that will be 24 pi I. That is 4 to the 36, the cosine of 24 pi, plus I the sine of 24 pi. That would be 4 to the 36, and again, 24 pi, we know ends up being there. That's a 1, that's a 0. So that turns out to be 4 to the 36. We know the location is on the positive x-axis. That's very important. If I move to the next problem down, so if I take negative radical 3, -1, r squared equal -1 squared plus negative radical 3 squared, r squared equal a 4, so r equal a 2. So this becomes a 2, and tan of theta equals the opposite over the adjacent. That must be at 30 degrees, which is a pi over 6. That's a reference angle, of course. Pi over 6 in the third quadrant is 7 pi over 6 times negative 20. Well, that would be 2 to the negative 20 e to the negative. If I take 7 pi over 6 and multiply it by negative 20, that would be a negative divided by 2. That's a 3 divided by 2. That's 10. That's 70 pi over 3. Negative 70 pi over 3. That would be 1 over 2 to the 20 times the cosine of negative 70 pi over 3 plus I, the sine. Okay, a bit more space will do. When to switch things, I have plenty of room. That would be 1 over 2 to the 20 times the cosine of negative 7 pi over 3 plus I, the sine of negative 70 pi over 3. That would be 1 over 2 to the 20. Now I know the values. The values would be the cosine of 7 pi over 3 is the adjacent over the hypotenuse, 1/2, plus I times radical 3 over 2. I just need to know where is 70 pi over 3. Pi over 3, if I start looking again, it seems to be a lot of work, but it's a lot easier than multiplying this by itself 20 times and dividing by it. So if I take that right there, if I go over 3, that is 6 pi over 3. So if I take 70 and divide it by 3, divided by 6, that will tell me how many loops I'm going to run, making that a mixed number. That is 1, that is 6, 10, 1, that is 6. So that is 11 full rounds and 4 pi over 3. So 4 pi over 3 is in quadrant. It happened to be in this quadrant, and in this quadrant we know cosine is negative and sine is negative. So that is negative 1 over 2 to the 21 minus I times radical 3 over 2 to the 21. So we're finding those. We're not saying why we need them, but when the time comes you would know. And the last problem, the same deal. We take 2 minus 2i. So we know r squared equals 4 plus 4, which is 8. R equal radical 8, which is 2 radical 2. So we know this is 2 radical 2. E tan of theta equals the opposite over the adjacent. If I ignore the sign and get the reference angle, we have a reference angle of pi over 4. In the fourth quadrant, the angle is 7 pi over 4. So that's going to be 2 to the 50th, and this is 2 to the 1/2 times 2 to the 25. E, and if I take 7 pi over 4 multiplied by 50, divided by 2, that is 7 times 35. Again, not a nice number, but it's easier than the alternative. 170 pi over 2. I, that would be 2 to the 75 times the cosine of 175 over 2 plus I, the sine of 175 divided. and that would be 2 to the 75 times. Well, if it's a multiple of pi over 2, I know that's 0, and I know that's a 1 or a negative 1. Let's see which one is it. Again, if I go one full round around the circle, that is 2 pi. To make it over 2, that is 4 pi over 2. So if I take 175 and divide it by 4, that is 4, 16, that is 3, 12, you have 3 left over, which means you're going to go 43 rounds, and you're going to start at, and you're going to go 3 times, 1 pi over 2, 2 pi over 2, 3 pi over 2, you're right there. That's a negative 1. And that would be negative 2 to the 75 I. I should have put the I after. There. Alternative is to multiply this by itself 50 times, and you will get that answer. So you can see in a few steps we're getting what will take several, I was going to say minutes, maybe hours to get the answer. Now comes the second part of this. Solve the solution. Solve the equation. Leave your answer in polar form. And we're going to sketch it too. So, z to the 6 minus I equals 0. This has to deal with fundamental theorem of calculus, a fundamental theorem of algebra, which says you should get 6 solutions. If you take the 6 root of both sides, that's only 2 solutions. And what does that even equal? So, in complex numbers, we can't figure it out just by using algebra. Instead, we're going to convert that to polar form. We're going to say I is right there. And obviously there's a 1 there, so you go up 1 unit. You're right there. So you're going to say z to the 6 equal 1 e to the pi over 2. Since that's a 6 and I need 6 solutions, I'm going to add 2 pi k. Isn't that the general solution? Can't you get it again by going one full revolution? So if you take the 6th root of both sides, you'll notice that z equal, we call it z sub k, equals e to the pi over 2 plus 2 pi k I raised to the 1 over 6. And if I get myself a bit more space, I'll find z sub k to be e, and if you multiply those, that's pi over 12 plus 2 pi over 6 k I. I want 6 solutions. That's very simple. Let k equal 0, k equal 1, k equal 2, k equal 3, k equal 4, k equal 5. If you go to equal 6, you repeat. K equal 0, z sub 0 will be, put a 0 right there, that's e to the pi over 12i. Z sub 1, e to the, if you take pi over 12 and add 2 pi over 6 to it, all over 12, that is pi plus 4, which is 5 pi over 12. Remember, we did this when we labeled our axis on the graphing sine and cosine. Z sub 2 equals, so what did you do? You added, where did the 4 come from? Over 12. So I added 4, add another 4. You could reduce, but since I'm going to graph it, add another 4, that is 13 pi over 12i, z sub 4, add another 4, 17 pi over 12i, and z sub 5 is going to equal, add another 4, 21 pi over 12i. If you go one more, that's e, add another 4, that's 25 pi over 12i. Isn't that the same as e to the pi over 12i? You start repeating. Now, to put this in perspective, we sketch a circle with a radius of 1, and what we do, we split this we need it over 12. We know this is pi, which is 12 pi over 12. So I need to split this into 12 equal parts. If I think of it as breaking it into 12, so 6 parts each. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, and 24. This is 1 pi over 12. This is 2 pi over 12. And what do I need out of those? I need to label pi over 12, 5, 1, 2, 3, 4, 5, 9, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, and 21. And this is good enough. Normally it looks like this. But no need to draw the lines. You could just draw the points and label at least those points and we're okay. And those should be all, oops, I clicked the wrong one. No errors. You should have 6 solutions. And you should label at least the 6 solutions. So that would be pi over 12, 5 pi over 12, 9 pi over 12, 13 pi over 12, 17 pi over 12, 21 pi over 12. That's 1, 2, 3, 4, 5, and 6. Those are called roots of unity. We have applications for those in engineering and science, so you should really get comfortable with those. I'm going to do a few more, actually 5 more, probably in the next video.